Okay, grade 11s. We were busy with intermolecular forces. We were looking at how does it form, and then we were looking at the different intermolecular forces. We looked at London forces, which we said are weak, very weak forces between temporary dipoles, meaning between molecules that are not permanently positive and negative. They are just formed like that for a split second, and we compared helium versus argon, and we saw because helium was smaller, it will have weaker London forces, and because argon is bigger, we said it will have stronger intermolecular forces. Then we looked at dipole-dipole forces, so that is between a permanent dipole, meaning it's always polar, meaning it's always one side negative, the other side positive. So between a dipole and another dipole, we have dipole-dipole forces. Then we looked at a special type of dipole-dipole force, hydrogen bonding, and we said it's called hydrogen bonding because it actually looks like a bond that is formed, but it is not a bond. They're just very close to one another, these molecules. Why? Because the one side is very positive and the other side is very negative. So it's like two very strong magnets that are attracted to one another. And now we're going to look at, we looked at 3 phases of water. Now we're going to look at ion dipole forces. Alright, so it's also very descriptive. It's between an ion. So what is an ion? An ion is something that is positive or something that is negative, and a dipole that has a positive and negative side. So we say a negative and a positive side, right? So it says that I want you actually to add it's a very strong electrostatic. Electrostatic again is positive and negative, or negative and negative, or positive, positive. Just between charged particles. Very strong electrostatic forces between permanent, actually I want to say between ions and permanent dipoles. Okay, so if we look here, you can see we have chlorine ion and a sodium ion. And then we have the water molecule around here. So this is oxygen that becomes slightly negative, and these are hydrogens that becomes slightly positive. So you can see between the negative ion, the chlorine ion, and the dipole molecule, there we have an ion dipole force. So you can write in there, we have an ion dipole force between them there. Alright. Now, how do we get those molecules? Most of the time it's when we dissolve a salt, like sodium chloride. This is a salt because it is an ionic compound. So we say S for solid. That dissolves in water to give us sodium aqueous and chlorine aqueous. Okay, so that is what we get there. So the aqueous stands for surrounded by water molecules. So here you can see you have the chlorine ion that is surrounded by the water molecule. So they didn't form a new bond. That's not a bond that forms. That is just a force between the negative and then the positive that keeps them close together. So you can say the chlorine ion is surrounded by water aqueous. Okay, so when we dissolve a salt in water, we get ion dipole forces. So now we're going to summarize the forces. First of all, we have London forces. They contain, or they have temporary dipoles, and they happen between, and I want you to write here molecules, they happen between non-polar and non-polar molecules. Alright, then the strength is very weak. We said they can easily be broken, and so that is why their melting and boiling points are very low. Then we looked at dipole-dipole forces, so they are between permanent dipoles. So they are between polar molecules and polar molecules. Okay, polar meaning they have a negative and they have a positive side. And those forces are not very weak, but it's relatively weak. So we just write weak, and the melting and the boiling points are thus relatively low. They're not very low, but they're not high. Then we have the hydrogen bonding, which is a very special type of dipole-dipole force. And we said they happen between, or they form a permanent dipole between hydrogen and north. Okay, so we said we look specifically at ammonia molecule and at the water molecule and at the hydrogen fluoride molecule this year. Next year we will look at more, but this year we will only focus on those three, and those three molecules that have hydrogen bonding. Now, why do we get those hydrogen bonding there? It's because it's between a polar molecule and another polar molecule, but more specifically than that, it is between hydrogen and a small high electronegative molecule. So hydrogen bonded to a very small highly electronegative molecule, you get a hydrogen bonding. Those forces are relatively strong and they have very high or relatively high melting and boiling points. Then the strongest force that we looked at is the ion dipole force, the one that we just looked at now. It's between ions and permanent dipoles, and most of the time it is between water and salty or ionic compounds. Okay, so when you see an ionic compound or salt dissolved in water, you will know that's an ion dipole force. They are very strong forces and they have relatively very high melting and boiling points. Okay, right. Now we're going to look at the effects of intermolecular forces. Now, intermolecular forces have different effects, and I actually want to do a practical with you guys, and I think I see you on Wednesday. So on Wednesday we will do the practical, and I think for that reason I'm just going to stop the lesson right now. What I want you to do for homework is on page 16. I want you to do number 1, just number 1, and there I want you to, for each one of them, you must write them in increasing order of being polar, but for each one of them I also want you to write the type of intermolecular force that they have. Right, enjoy your day, grade 11s.